Integration is all about remembering the standard results and converting the existing integral into the integral whose solution is known to us. And therefore, it is extremely important that you remember all the standard integrals, that is number one. And if you wish to solve complicated problems, then you need to remember some not standard but non-standard integrals, considering them to be standard. However, the 6 integrals that I have written on board are standard, and therefore you need to remember them. And there is every chance that you remember integral of 4 as integral of 1 and integral of 1 as integral of 6. So I give you 4-5 minutes now to cross check and fix it in your mind, and then randomly I will ask what is the integral of 4. You should be instantaneously able to tell what should be the answer by looking into the camera, not here and there. I mean, I used to do this in the class. Let us see whether we can do it online or not. So I give you 3 to 4 minutes to remember the results. Okay. After having learnt formula for these 6 standard integrals, let us solve few problems now. Problem number 36. Integral dx upon 4 plus 5 sin square theta. अरे sin square x वरती x आणि खाली theta असं नाही चालत ना. It should be sin square x. We have to use them to solve problems. And now this is tricky because if you have tan in the denominator and sec square x in the numerator, you can solve it. Solve anything. नाही काहीतरी चुकलं. 4 multiplying numerator and denominator by sec square x, you get 4 sec square x plus 5 tan square x. That is integral sec square x dx divided by 4 plus 9 tan square x. Put 3 tan x is equal to t, right? Therefore 3 sec square x dx is equal to dt. Therefore sec square x dx is equal to 1 upon 3 integral dt upon 4 plus t square. This is standard. Problem number 4, and hence answer for problem number 4 is 1 upon 3 into 1 upon 3 is original, 1 upon a is 2, tan inverse t by 2, where t is let us quickly do it. This is equal to integral cos x dx divided by radical 1 minus 2 sin square x is equal to putting root 2 sin x is equal to t. So if we put root 2 sin x is equal to t, we get dt upon root 2 is equal to cos x dx. Hence the integral reduces 1 upon root 2 dt upon radical 1 minus t square. So the answer is 1 root 2 sin inverse t, which is root 2 sin x plus c. Straightforward. I mean, the first step is important, substitution is important. Question 38.
सर
Yes.
सर जर आपण त्याला cos 2x ला 2 cos square x minus 1 दिलं तर
तर सॉल्व होत असेल तर बरोबर चेक करायचं सॉल्व होतंय का, जर झालं तर बरोबर, आणि मग आलेलं उत्तर आणि हे उत्तर सेम आहे का पण ते चेक करा.
तर माझं थोडं वेगळं येतंय म्हणजे
ऐक ना, जनरली ऐक जरा ट्रिक काय आहे, जनरली जो dx च्या शेजारी असेल, द वन हु इज along with dx, if it is a derivative then it is easy. Cos x is derivative of sin x, so your attempt should be to get sin x in the denominator. Otherwise
नाही सर म्हणजे जर आपण तसं घेतलं की 2 cos square x minus 1 तर मग आपण न्यूमरेटर आणि डिनॉमिनेटरला cos x ने डिवाइड करायचं, म्हणजे मग वरती फक्त dx राहतं आणि मग डायरेक्ट पहिला वाला फॉर्म्युला वापरायचा.
बरोबर, which is equal to dx upon 2 minus sec square x. बरोबर.
हो सर, रूट 4.
आणि मग काय केलंस,
मग तो पहिला वाला फॉर्म्युला वापरला साइन इनवर्सचा.
6 पैकी पहिला नाही,
हो सर.
फॉर्म्युला वापरला म्हणजे सबस्टिट्यूशन काय आहे, फॉर्म्युला वापरायची अजून स्टेज आली नाहीये. अरे माय डिअर श्लोक, गायब.
कळलं सर.
तुम्ही याचं डेरिव्हेटिव्ह इथे कुठे सपोर्टला नसेल तर कसं येणार आहे ते, सपोर्ट विसरायचं नाहीये. आता मला कलर चेंज करायला हवा, इंटिग्रल कलर चेंज, इंटिग्रल सोपं आहे, करा पटकन. sec x tan x dx divided by 25 minus 16 sec square x dx लिहून झाला, is equal to question 38. Okay, if we assume that, okay, let us first step is put 4 sec x. This implies 4 sec x tan x dx is equal to dt. Therefore sec x tan x dx is equal to dt upon 4. So the integral becomes 1 upon 4 integral dt upon 25 minus t square, which is 5 square minus t square. Okay, so this is a square minus x square type, and therefore if we directly want to write down the formula, 1 upon 4 into 1 upon 10 2a log a minus x 5 minus 4 sec x upon 5 plus 4 sec x. This is true if 5a is greater than t is 4 sec x. Else, what will happen? Right. Change करायला. Else, the answer would be if t square is greater than 25 square, then what will happen is, I mean, same answer is equal to minus 1 upon 4 integral dt upon t square minus 5 square. If t square is greater than 5 square, then the answer would be 1 upon 4 into 1 upon 10 log t, I mean 5 plus 4 sec x upon 5 minus 4 sec x plus c, and both of them are same. Because this minus sign is there outside, this will be, and then again this flipping will take place if I take that minus here. Am I doing it correctly? Please cross check.
तर दुसऱ्या याच्यात डिनॉमिनेटर मध्ये 4 sec x minus 5 पाहिजे ना.
A minus x लिहिलं होतं ना फॉर्म्युला आपण तो चेक कर. A minus x डिनॉमिनेटर.
तर पण मग पहिल्या फॉर्म्युला मध्ये आपण x minus a लिहायला पाहिजे ना न्यूमरेटर मध्ये.
थांबा गोल मारतोय तुम्ही सगळेच. Okay, whatever is there between x minus a upon x plus a, if x square is less than a square, if x square is greater than a square,
Excuse me, sir.
yes.
Sir, I think in the first one, since the formula that we have written is
Okay. Now, once we do this substitution, 4 x is equal to t, we get the integral reduced to dt upon 5 square minus t square. So, these are the two standard formulae that we have learned. If x square is greater than a square, that is x is greater than a, then this is the formula, x is greater than a, and if a square minus x square in the denominator where x is less than a, we get this formula. Okay, so if you look at the sec x, if it is greater than 0, then 4 times sec x will belong to closed interval 4 to plus infinity, and hence t square will belong to 16 to plus infinity. And if sec x is less than 0, t will belong to minus 4 to plus infinity, but eventually we are squaring, therefore t square will belong to this. Now, so far t square becomes 25 when the denominator becomes 0. It doesn't make any sense. Hence we have two conditions. When t belongs to 4 to 5, when t belongs to 4 to 5, t square is less than 25. And hence we have this answer as per this formula. And when t square is greater than 25, that is t is between 5 to plus infinity, we have answer using this formula. So these are the two answers for problem number 38. Question 39. Dx upon 1 plus cos 2x into 1 minus tan square x integral is equal to. Correct. Let me write down one solution. This is equal to 1 half integral sec square x dx upon 1 minus tan square x. Trigonometrically it is this. So putting tan x is equal to t, we get integral dt upon half dt upon 1 minus t square, which is equal to 1 half log t is what, tan x. परत एकदा प्रॉब्लेम येणार ते कन्सिडरेशनला, पण आता ठीक आहे. 1 प्लस tan x upon 1 minus tan x plus c. What is the other method? Maybe that is better or safe. What do we do?
For sec square x, we take in the denominator as cos square x. And then the denominator becomes cos square x minus sin square x, which is cos 2x. We directly get it in sec 2x form.
Okay. Cos square x minus sin square x, that is cos 2x. Okay, this integral is equal to integral dx upon cos square x 1 plus cos 2x is 2 cos square x. That 1 by 2 comes out. Inside bracket 1 minus tan square x makes it 1 upon 2 integral dx upon cos square x minus sin square x, which is cos 2x, which is integral dx upon integral sec x, sec 2x dx. Oh, good. So if you want to write it as d2x, then that becomes 1 by 4. So what is your answer? 1 by 4 log sec 2x plus tan 2x plus c. That is also correct. Good. Okay. I hope everybody is understanding and writing the required details. Question 40. Change the color.
सर क्वेश्चन 39 मध्ये फर्स्ट मेथडचं जे आन्सर आलंय तर त्याच्यात 1/4 असायला पाहिजे ना, तर सुरुवातीला त्याच्यात
Oh, half आणि मग 2a. Correct. Yes. पण मग मी 1 by 2 का लिहिलंय? 1 by 4 पाहिजे. बरोबर. Now 40. Now this is a celebrated problem, dx upon x raised to 4 plus 1. I will wait for किती मिनिटं थांबू? 12 मिनिटं थांबतो. Wait for 12 minutes. And then give you hint. Now this is, as I said, is a celebrated problem because it requires many adjustments to get under control. Suppose you were given Can you solve? Can you solve this? If suppose for you there is a support of x square plus 1 in the numerator, can you deal with it? Check. Okay. If it is still difficult, maybe let us check integral 1 plus 1 over x square dx upon x square plus 1 over x square. Can we solve? Okay, I think this should be doable because this is equal to integral 1 plus 1 upon x square dx divided by divided by x minus 1 upon x bracket square plus 2. Can be solved. काढा बघूया उत्तर. Okay, those who are solving, I have shown you how to go about the some part of the final problem, number 40. Now you should be able to get the answer for dx upon x raised to 4 plus 1. So finished, can start solving this. Integral question 41. Radical tan x dx. This is also celebrated problem. Try your best. Solving this. Now this is doable because if you assume, say, x minus 1 upon x is equal to t, then derivative is the numerator. 1 plus 1 upon x square dx is equal to dt. Therefore, this reduces to dt upon t square plus 2 integral, which turns out to be 1 upon root 2 tan inverse t upon root 2. And if we replace t by this, that is what is our integral of x square plus 1 upon x4 plus 1 dx. However, this is not given to us. What is given to us is I is equal to integral x square plus 1 minus x square minus 1 divided by x raised to 4 plus 1 dx. And what we are doing is unnecessarily multiplying numerator by 2, so we should have half outside. That makes it half instead of integral x square plus 1 divided by x4 plus 1 dx minus integral x square minus 1 upon x4 plus 1 dx. This is going to be equal to half I1 minus I2. This is our I1. Okay. So what is our I2? Our I2 is going to be our I2 is going to be integral x square minus 1 upon x4 plus 1 dx, which is equal to integral 1 minus 1 upon x square divided by x square plus 1 upon x square dx, which is equal to 1 minus 1 upon x square dx integral denominator x plus 1 upon x bracket square minus 2. Let x plus 1 upon x is equal to t, implies 1 minus 1 upon x square dx is equal to dt. Therefore, I2 is equal to dt upon t square minus 2 integral, which is equal to 1 upon 2 root 2 log t minus root 2 upon t plus root 2 plus c we will add in the end. Okay, if you replace t by this expression, your answer is ready for I2, and therefore the final answer for I1 minus I2 is I is equal to I1 minus I2 is equal to 1 upon 2 root 2 tan inverse x square minus 1 upon root 2x minus 1 upon 4 root 2 log x square minus root 2x plus 1 upon x square plus root 2x plus 1 plus this is what is your answer. Any questions? No. Good. In that case, we should solve 41.
Sure.
Yes, coming. So the substitution is 10x is equal to t square. Okay, so therefore sec square x dx is equal to 2t dt, right? Therefore tan square x plus 1 dx is equal to 2t dt. Tan square again we substitute tan square, then it will be t square plus 1 dx. So dx is equal to 2t upon t square plus 1 dt. So this will be
तर ते T4 T raised to 4 पाहिजे ना.
right? काय झालं t raised to 4 पाहिजे नाही का?
tan square म्हणजे T raised to 4 होईल ना.
केलं 2t upon t4 plus 1, and then you have tan x is equal to t square, radical t square is t into 2t, so this equation becomes 2t square upon the t4 plus 1 dt. Is that okay? Which you can do 2 inside bracket t square plus 1 upon t4 plus 1 integral minus integral 1 upon t4 plus 1 dt. And now both of them we have solved. Therefore, the final answer is, in terms of t, you have to solve and then substitute tan x in root tan x in place of t, and the final answer is 1 upon root 2 tan inverse inside bracket 1 upon root 2 inside bracket tan x minus 1 upon root tan x plus 1 upon 2 root 2 log inside bracket tan x minus tan x minus radical 2 tan x plus 1 divided by tan x plus radical 2 tan x plus 1 bracket complete. What is this? This is bracket complete here. Yes. Plus. That is what is your final answer. Now, that is why integration is promising. Can you think of this being antiderivative of such a simple function radical tan x? I mean, nobody will dare to differentiate this, but if at all somebody starts doing it, eventually if all algebra, all derivatives, all chain rules are correct, you are supposed to get this reduced to root tan x. When if you are frustrated sometime, if you are not fine, you start differentiating this, simplify, and if you happen to get root tan x, you will feel very happy about yourself. Maybe you can try. Steps that we have performed for solving this integral were technically correct, and therefore we can say that yes, this is the integral of root tan x. Now I have two options. Okay, as per our earlier plan, we will continue with the same plan. This weekend. Why am I recording?